Good afternoon everyone, I am Mr. Rich. Thank you for joining me for this video. In this video we are doing exactly what we have here, an optimization problem where when you are given a limiting constraint or a resource, you have to do the maximum you can with that. And our limiting resource is exactly this right here. We have 100 meters of fence. 100 meters of fencing, and what is the maximum enclosed area we can determine, and you are going to divide it as such as you see it right over here, a 3-part enclosure, and you're going to divide everything here among the 100 meters of fencing. What is the maximum area that can be determined? If this right here represents my width and all of this is my length, we can use this as an x. There's x meters of fencing utilized here, there's x meters used here, x here and x here. You're using that much already in terms of your fencing. Out of how much? You're using that out of a total of 100. So I am starting here with 100, and I've already used here in terms of the width components 100 minus 4x. That's what has been used. This also represents what remains. What remains is now we have to get these two lengths. You know there are two of those sides, you divide it by 2. And now look at exactly how everything plays out. When you do 100 minus 4x divided by 2, you can simplify it. You have 50 minus 2x. This represents my length. My width in all instances is x. Now if technically you wanted to, you can ignore these central partitions and you're really looking here at just a large rectangle. Technically that's all you're looking at. Area with regards to x is now equal to length times width. X times 50 minus 2x. You have to optimize this and you have to determine what the value of x is, because then that will give you the values of your length and width. And remember, all of this procedure is called optimization. You have to open that up. You have area with regards to x is equal to minus 2x squared plus 50x. Here a good idea is to convert this into the standard form of a parabola, a into x minus h whole square plus k, because when you do that it'll give you exactly what you need here in terms of a vertex. Vertex here is h comma k. This will represent your maximum area, and this right here will represent here, the h will be your dimension, which I'm just abbreviating as DIM, dimension and maximum area. You have to complete the square over here. Let's do it. You have minus 2 brought out, you have x squared minus 25x. Now complete the square. When you complete the square, I'm going to do it right here. Minus 2, you have x squared minus 25 divided by 2. Well, minus 25 divided by 2, and you have to square that. I'm getting here a minus 25x over 2 plus 156.25. 156.25. All of this is equal to exactly this times that minus 2. Because it's going to go out on the other side as exactly as what you see it, minus 312.5. Remember, this right here is me doing the completing the square. Now I'm going to complete the square in terms of a proper answer. I'm here getting an x. Here I'm going to get what? 12.5 square plus 312.5. I took the minus 312.5, I took it on the other side of the equal sign, is equal to 0, or you can say is equal to your area with regards to x. Anyhow, you see how I've converted this into exactly this form right here? A into x minus h whole square plus k. It's alright if the sign here is negative. It just means you're having a parabola which is pointing down. You have a parabola that's pointing downwards, and there's nothing wrong with a parabola pointing down, because this right here, the top, the apex of this parabola represents your max, the maximum. And that's exactly why this is a maximum optimization problem. You can have parabolas which point downwards, but look what we've determined here. We've determined our h comma k. Here's my h, here's my k, and it's 12.5 comma 312.5. This right here will tell you exactly what you need. You'll have a dimension here of 12.5. You'll have a maximum area achieved of 312.5, and we can verify it. Look at this 12.5 and plug it right here in place of this x. I'm getting here a 12.5 because x is equal to 12.5. Remember, don't bring in the quadratic formula for this type of question. There's no need. Do completing by the square, because it will give you the answer in a good format, which will separate the two items for you, your dimension and your maximum. Now bring the 12.5 right in here. You do 50 minus 12.5 times 2. You're getting here 25. So the maximum dimensions you need is this. Your length will be here 25. And your this right here will be 12.5, and everything will check out, and I'll show you how everything will check out. I have 1, 2, 3, 4 of these 12.5. I'll do 12.5 times 4 because I have 4 of those. but I have two of these 25s, plus 25 plus another 25, and I've hit my 100 meters of fencing, so we're good. The question was, given 100 meters of fencing, what is the maximum enclosed area if the area has to be divided as such? A 3-partition corral which has a rectangular shape, and you started out with these x in terms of your widths, then you had your remaining amount which was designated into the length, 100 minus 4x divided by 2, because there are two lengths. It gave you 50 minus 2x. You go through this completing by the square technique to get this standard form of a parabola from a quadratic equation. This right here is my quadratic equation right here, minus 2x squared plus 50x. You convert the quadratic equation into your standard form, which you see right over here, minus 2 parentheses x minus 12.5 whole square plus 312.5. That standard form of the parabola is beautiful because the vertex represents your dimension and your maximum. Take one of those dimensions, put it in terms of x, and solve for the other dimension, and you're good. 12.5 is the width for each of these x's, 25 for each of the lengths. The total enclosure, 312.5 meters square, and the question has been solved. So this is how you do these type of problems, and this right here is very much at the level of 12th grade mathematics for high school, and you can see this. And thank you for joining me for this particular video. Have a great day. Bye.